Hey guys, we are going to keep talking about these functions and relations. So let me give you a couple reminders. First off, remember what a relation is. All it is a set of ordered pairs. Now they might give you that relation as an actual set of ordered pairs. Oops, gotta be able to write here. In this type of notation. They might give it to you in a T-chart. They might give it to you in a graph. Okay, any of those are relations, and that's fine. They can give it to you in any of those. It could even be a line. It doesn't just have to be the points. So those are relations. Remember, a domain is all of your inputs or your x values, and your range is all of your outputs, your y values. Okay? Independent variable is your domain, your x. Dependent variable would be your range, your y. Okay, so just a reminder there. More reminders. What is a function? It's a relation, so what we just talked about here, but specifically, it's where each number in the domain is paired with exactly one number in the range. And the easy way to think about that, each x has only one y. Okay, so just reminders here on what we're talking about. We did this in 2.1, okay, trying to determine if a relation is a function. This specifically is asking for a mapping. Remember what that looks like. You take all of your x values and you list them. If anything were to appear more than once, you would only list it one time. You take all your y values and you list those. And here 2.5's twice for my y's, but I'm only going to write it once. Then you draw arrows to what's connected. So -2 goes to 0.5, 0 goes to 2.5, 4 to 6.5, and 5 to 2.5. So this is your mapping. Now, is that a function? Keep in mind your definition of function. Each x goes to only one y. 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 So each number in your x column is only matched with one y. So yes, this would be a function. It does not matter that 0 and 5 go to the same y. Everything could go to the same y, as long as each of those x's is only going to one y. Okay, so refreshing your memory there from 4.1 and 4.2 also. All right, another way to tell if something is a function is by looking at its graph and doing what we call the vertical line test. If any vertical line, remember, up and down, passes through more than one point of a graph, then that relation is not a function. So pause the video, get that down. If any vertical line passes through more than one point of a graph, the relation is not a function. So let's look at some examples. On my first graph, you have to literally imagine drawing vertical lines through your graph. Like, just keep drawing them. And whoops, that's totally not vertical. Make them straight. I guess my first one isn't really either. But if I'm drawing these vertical lines through here, am I ever touching more than one purple spot? Am I ever hitting that line more than once? And the answer would be no. Okay, so that makes it a, function. If any vertical line passes through the point, if it passes through more than one point of a graph, it's not a function. So that means if it only ever touches one point, it is a function. Okay, so try again. Nope, that's just once. And again, these aren't perfect, but you get the idea. I thought there was a button I could press that would make them perfect, but maybe not. Just one there. Yep, these are all just hitting one. Well, that one went a little crooked, just a little. Now on your paper, do you actually have to draw all these lines? No, you really should just be thinking this in your head. Certainly you can if you want to, but you don't have to. So every vertical line I drew there, through those points only ever touch one point. That makes it a function. Okay, so vertical lines here, always only going to hit one point. Function. So all three of these are all functions. So let's look at what would be not a function then. If I dropped a vertical line through this one, how many points is it hitting? A whole lot more than one, right? It's hitting all of these points all the way up. That makes it not a function. If your vertical line hits more than one point, it's not a function. Looking here, let's do this one just imagining. This would only hit one, this would only hit one, this would, right here. That just hit two. It hit one right here and one right here. That makes it not a function. And why would this be? Why would these not be functions? Well, what is the x value of that? It looks to be about -4. Well, then this one would be +3, and then the other one would be -4, +6. But each x value can only have one y value. So if you drop a vertical line and it hits more than one point, that means there was an x value that had more than one y value. And that makes it not a function. And lastly on this one, very clearly here you would be hitting 2 points in many different places dropping vertical lines. So that is not a function as well. Okay? Hopefully you see the difference between those. Something to note is we have said before that all linear graphs are functions with one exception, and that would be a vertical line. Okay? So let's maybe jot that down real quick. All linear graphs, which means graphs that are straight lines, except vertical lines, which we know vertical lines have the equation x equals some number. Okay, so if you have y equals a number, that's fine. That would be a horizontal line. That would definitely be a function. But a vertical line would have the equation x equals a number, and that is not a function. Okay, use the vertical line test to determine if the relation is a function. You guys go ahead and do this. You can plot these real quick on a coordinate plane, and then this one I would like you to graph in your calculator if you are at school watching this. If you're at home watching it and you don't have a graphing calculator, remember you can go to Desmos, DESMOS.com, and you will be able to graph there. So plot these by hand, graph this one in a graphing calculator or on Desmos, and see if it passes the vertical line test. Okay, taking a look at the first one, your ordered pairs, you should find that this is not a function because the vertical line right here would hit 2 points. And that is from the -4, 2 and the -4, -1. So you probably already knew it wasn't going to be a function based on your work in the last two sections, but I still wanted you to go ahead and graph that. So make sure you have that in your notes. The second one, excuse me, I am going to show it to you on the graphing calculator. Remember how you would get that? You would go to your graphing screen, press tab, and remember that this f1 of x, which we're going to talk about more in this video, is the same thing as y equals. So we only have to write the stuff after the y equals. And that would be the -x² + 3. So looking at this graph, it does pass the vertical line test. Sometimes students think that it's starting to flatten out right there, but it wouldn't. It would keep moving on forever outward. So none of your vertical lines would hit more than 1 point. Let's look at it on Desmos as well. If you go to Desmos.com, you have to click Start Graphing. And then, I gotta see what the equation was. Y equals -x² + 3. You just type that in. Y equals -x² x. How would you get a square? You just need to go your caret, which is shift 6 to get up in there, and then arrow over to get out of it, just like we do on our calculators. Was it plus 3? Yep. Okay. And right as you're typing, notice that it starts changing. So here would be negative x squared, but then we want plus 3, and it does that for you exactly as you're typing. This is a really neat program if you want to play around with it a little more. But just typing it in, there we go, same graph we had on our calculator, and you can see that it will pass the vertical line test just like we thought. Okay? All right. The main idea really in this section is something called function notation. If you have a function, which now we know how to tell if we have a function, whether you're looking at a mapping or a graph, you can tell if something's a function. If it is, it can be written in a form called function notation. Normally, we are used to working with equations that look like this, y equals 2x plus 3. But what function notation does is it takes that y and it turns it into what we call f of x. Okay, we pronounce this f of x. What that actually means is that you have a function in terms of x. What does that mean, a function in terms of x? It means you have a function with x in it. Okay, so why is this notation, why do we use it? Well, A, it's better. It's better than this notation because if I'm looking at this right here, if I just have an equation, I don't know if it's a function or not. I would have to graph it or plot points. I would have to determine if it was a function. But if I'm working in function notation, I already know it's a function. I don't have to worry about that. And maybe you weren't worried about it anyway, but you should be because you're going to have questions that are asking if things are functions. And if it's in function notation, you can very easily say, yep, that's a function. You don't have to do any other work. Okay? But this f of x is really the exact same thing as y. F of x is y. It means the same exact thing. Okay, but the advantage is you know it's a function. You know what variable is going to be in it. So if I don't even have to look at this side at all, I know I'm working with a function and it's going to have x in it. If I'm looking at this side, I have no idea what it's talking about. I don't know if it's a function or not, and I don't know what variable it's going to use. Okay? Now, what are we going to do with this function notation? Do you remember previously in last year and in the beginning of this year, we had problems where maybe it said solve or simplify. I won't use the word simplify. If x equals 2. So if I'm saying x equals 2, what should you be doing? Well, you would plug this in, right? You would do substitution. So we would have y equals 2 times 2 plus 3, and 2 times 2 is 4, plus 3 would be 7. Y equals 7. Okay, so remember problems like that? Well, function notation does that a lot, but they're not going to give you all these directions. All they are going to say is find f of 2. What is that actually telling you to do? It's telling you to take out what you had in this parenthesis and put the 2 in its place. But don't just do it on the left side, do it over here as well. So finding f of 2 is just a fancy way of saying, hey, plug 2 in for x and simplify or solve or substitute. just a quicker way to say it. Find f of 2. So we would say that f of 2 equals, now you're going to substitute this 2 in for the x. So here's our 2 from there. Then instead of our x, we're taking x out and we are substituting 2 in its place, and then plus 3. So then we have that f of 2 equals 4 plus 3, and then we have that f of 2 equals 7. Same thing we came out with over here. Now when students first learn this, a lot of times what they want to do is keep going. And they will be like, oh, well, this is parentheses, so that must mean I have multiplication here. So I probably need to divide by 2 and solve for f. This is a very common mistake. Don't do this. Okay? F is not a variable. F is the name of this function. F is the name of this function. So we're not solving for f. We know what f is. F is 2x plus 3. So we're not trying to solve for f. All we are trying to find, all we are trying to find is what f of 2 is equal to. Oh my gosh. There we go. So right here you are done. F of 2 is 7. That's what you're trying to find. So why, again, is this notation better than our old notation? Well, in our old notation, when I have y equals 7, I don't know what that came from. I have no idea what I plugged in, and I don't know what I plugged it into. But in this notation, I know I plugged in 2, and I know I plugged it into my f function. So you get more information out of your answer versus the old way. This says I have a function named f. I plugged 2 into it, and I got 7 out. Over here, I don't know what I plugged in. Now, obviously, I could go back up and look, but if somebody else is looking at your work, this is a better way to write it. Okay, so a lot of the times going forward here, we're going to strictly be using function notation. So even maybe you're graphing a line, you might not see it as y equals mx plus b anymore. You might see it as f of x equals mx plus b. Okay, so we're just going to have to get used to that shift that y and f of x really mean the same thing. Let's try a few more. So here's a new function. Oh, and by the way, it doesn't have to be called f. Generally it is because f for function. They also use g of x a lot and h of x a lot, but really it could be any variable. You could have s of x. You could have a of x. It doesn't matter. That f could really be anything. It's just that's the name of that particular function. All right, but this one is f of x. It's equal to 2x minus 9. Find each value. So find f of 6. So f of 6 would be found by taking 6 and plugging it in for your x. You just substitute what's in parentheses in for your x because we already knew what f of x was. Now we want to know what f of 6 is. So the x becomes a 6, so it also has to become a 6 right there. And then it's just calculating it. 2 times 6 is 12. 12 minus 9 is 3. At that point, you are done. Do not try to go further. This does not mean multiplication between these two things. This is not multiplication. No, it is not. Don't write that. It is just saying you had a function and you plugged 6 in. Okay, so from that, we get all that information. We know we took a function named f, we plugged 6 in, and we got 3 out. So our input was 6 into our function f, and our output was 3. Okay, f of negative 2. So we are taking the x out of f of x and plugging in negative 2. F of negative 2 equals negative 4 minus 9. F of negative 2 equals negative 13. Do I have to see this step right here? No. You don't have to show me that. You can do that all with mental math all at once, or you can stick the whole thing, and by the whole thing I mean this part, in your calculator. You obviously wouldn't put this part of the equal sign. Okay? Sometimes students get lazy on me and they will do this problem and they'll write f of x equals 2 times negative 2 minus 9, and they'll say f of x equals negative 13. This is wrong, and I will mark it off. f of x does not equal negative 13. F of x equals 2x minus 9. F of negative 2 equals negative 13. So you need to make sure you are doing the notation correctly. F of x is just this. As soon as you plug something else into it, you're not working with f of x anymore. You're working with f of whatever you're plugging in. Okay, so again, I will take off if you do that. Sometimes what you plug in is another variable. Sometimes it's an expression like this one. And that's okay. That's just whatever's in there, plug it in. I don't care if it's a monkey in there. Plug the monkey into the equation. So f of k plus 1 equals 2 times k plus 1 minus 9. F of k plus 1 equals, got to do some distributive property here, 2k plus 2 minus 9. So then f of k plus 1 equals, combine your like terms, 2k is the only one there, and then plus 2 and minus 9 are like terms, so negative 7. That's your answer. You're not solving for k. You're not going any further. This is all you can do. You simplify that side, and you are done. All right, pause the video and try these two. Okay, check your answers on these. H of negative 3 should be 30. If you got 12 or negative 12, you are messing up your signs. When you plug into this, whatever number you're plugging in for the z's, you want to put in parentheses. The square would not go in the parenthesis. The negative 4 would not go in the parenthesis. Just what you are plugging in goes in there. So if you got 12 or negative 12, you did not use the parentheses correctly. Sometimes I will have students, they'll take the negative 3 and they'll plug it in. And they'll say, well, my calculator told me it's negative 9. And I'm telling you it's 9. Your calculator isn't wrong. You're typing the wrong thing into your calculator. If you type in negative 3 squared like this, the calculator is only going to square the 3. It's not going to square the negative sign. So the negative would just get brought down, and 3 squared would be 9. So it would give you an answer of negative 9, which is correct for that. However, if you do it the correct way you're supposed to, then it's going to square the negative 3, the whole thing, which means what it's really doing is negative 3 times negative 3, and those two negatives would make a positive 9. Okay, so you need to pay attention to how you should be typing it in, and you definitely need parentheses here. Okay, if this negative sign were not part of the number you're plugging in, maybe that wasn't there, but there were a negative sign out front of the variable like this, then it would be this situation. You need to understand the difference between those. If you do not, mark it on your paper, and whenever you see me next, come ask me about it, because this is very important and it will continue to happen on all of your problems. So come see me if you need that further explained. And then h of 5c, you're plugging in 5c. 5c squared, you've got to square both pieces, so 25c squared. Don't forget the square on the c. Minus 20c plus 9. None of those are like terms, so you are done. One more to think about. This is a little different. It looks a little different than what we were doing before. Okay, it's not the same thing as what's up there. It still has the same numbers and letters, but it's done differently. Ignore this 5 for a second. H of C would just be telling you to plug C in where the Z's are. And that's really all you would do. Okay, your Z's just become C's. But then this 5 out front, what do you think it's telling you to do there? It's telling you to multiply everything by 5. So everything here, we're going to multiply by 5. So it's just like distributive property. So 5c squared minus 20c plus 45. All right, last thing in this section is finding a reasonable domain and range. So you have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet. The function a of q, there's our function notation, and it's not f of x, that's okay. It's a for area, q for quarts, equals 100 q. Okay, so area is a of q in square feet. Q is the quarts of paint. What domain and range are reasonable for the function? Domain, of course, is our x values. In here, we don't have an x, we have a what? We have a q. So for your domain, what you're trying to figure out is how many quarts of paint would make sense here. Well, it says right here you have 3 quarts of paint. So certainly I would say we could have a 3 in our domain. What else could you have in your domain? Well, could you use 2 quarts of paint? Sure. 1 quart of paint? Sure. Could you not use any paint at all? Yeah, maybe if you're not doing it. Could you use negative paint? No, negative paint doesn't make sense. So that should be telling you that your Q has to be greater than or equal to 0. Okay. And it would have to be less than or equal to what? 3, because that's the most amount of paint you have. So another way to write this is Q less than or equal to 3, same thing here, but you can combine this one and write it this way. So I just kind of flipped it around, right? Q is greater than or equal to 0. Well, that's the same thing here as saying 0 is less than or equal to Q. So your domain, your Q, your input value has to be between 0 and 3. Notice that it's between them here. It's got to be between those two numbers, 0 and 3. You can't use less than 0 paint. You can't use more than 3 quarts of paint, because that's all you have. Your range would be your Y values, your, in this case, A of Q values. And it would be what you would get if you use these amounts of paint. So use your least amount of paint. If you use 0 paint, no paint at all, how much area is that paint going to cover? Well, it's not going to cover any area. You're not using any of it. So you would still get a 0 less than or equal to your area, which, remember, you could read this the other way. Your area would be greater than or equal to 0. In that case, it would be 0. And your area would have to be less than or equal to what if you used all 3 quarts of paint? Well, you would find that just by taking 3 and plugging it in to your A of Q function. A of Q equals 100Q. So I plug 3 in, and I get that A of 3 equals 300. So if I use all 3 quarts of paint, I could cover 300 square feet, and that would be my range. That would be my output. My input was 3, my output was 300. So once you find your domain, and that'll be given to you by the specifications of the problem, by having 3 quarts of paint here, then all you're going to do is plug each value in to find your output, your range. So really we could have plugged in A of 0, and of course that would give us 0. But we kind of just thought through that one, and that's fine. So there's your 0 for your range when 0 was your input. And when 3 is in your domain, when it's your input, your output was 300, gotten from right here. Okay? I'm going to have lots of function notation practice, and then some of these as well. Let me know if you have questions. Please stay on pace.